In this video, we're going to look at how we apply some loads to our concrete bending cross-section. This model has two rectangular areas that define the boundaries of the concrete bending cross-section. In order to work with loads, we first switch to the loads ribbon, and once at the loads ribbon, let's talk about what's visible. Very important part of the loads ribbon is the service case drop-down combination box. Currently it's set to D for dead loads. If I click on the combination box, I see other possible load sources available. Notice that if there are no loads for a given load source, it'll appear hazy with the number 0 in front of the source. So we're going to leave that set at dead loads, but you would switch this if you wanted to get loads into other sources. The first kind of load I'm going to talk about is a point load that you would apply to your structure. To do that, it's a two-step process. We first have to create the points where the loads will be placed. So in the ribbon, I'm going to click on Place Load Points. And then on my model, I'm just going to use my mouse and click on a couple of locations. I'll hit the Escape key to remove the drawing mode and get back to draw nothing. If we look at what we just drew, we see that there is a green line surrounding, in this case, a red circle. Each one of these load points has properties that we set up in the inspector. So if I select a load point, I can look over in the inspector and I see I have its name and its location. In addition, the shape of the load point. I have the option of making the shape square, rectangular, circular, or an octagon, and I can enter the size of the particular shape. In addition, I can rotate the shape. If I make this shape, let's say circular, you notice that the green outline around our load point changes to demonstrate a circle. The green outline represents the punching shear boundary that's used in the design calculations for this load point. So it's important that you get the properties for this load point set up properly. Typical load point sources would be things like columns or possibly a base plate resting on our wall or slab. So now that we have the load points made, how do we actually create a load? To do that, we'll select one of the load points, and then up in the ribbon, we will click on the Apply Load button. And when I do that, we see over in the inspector, we have a load with the force Z of -1 kip and no moment about either the X or Y axis. The sign convention for force Z means negative means it's going into the plane that we're viewing or in the negative Z direction. This would be typical for a column load coming down on a slab, for example. It would be a negative value. So that's how we create concentrated loads on our slab. Let's also look at how we would apply loads to beams. To do that, I'm going to go back to our boundary and support ribbon, select Draw Beams, and I'm going to draw a beam on our cross section. Now that I've done that, I can go to the loads ribbon again, and when I do that, we'll see that the beam is still currently selected, and by having it selected, I can hit the Apply Load button again, and this time I'm applying a load along the beam. And currently we have the ability to enter a load along the beam as a resultant force, which would be evenly distributed, and right now it's a 1 kip force evenly distributed. I can change that, and by doing that I can change and enter a uniform load and the resultant unit moment along the length. If I rotate my structure a little bit, we can take a look graphically at these loads that I've just created, and we see the uniform line load across the beam and the point load at the load point. Editing these is done with the typical way we edit in our products, in that if we select them, we can go to the inspector and change values. So I can do that for the point load and change its values. In addition, if something's selected, I can hit the delete key and remove it from the model. So that's a quick summary then on how we add load points and concentrated loads as well as line loads to beam elements.